Hi, it's another Monday math day. So today at the noon hour, we're going to be talking about ratios. So ratios are huge in sixth grade. So if you have fifth graders, sixth graders, seventh graders, but they carry on all through the sciences in high school and all over. And a lot of you do ratios all the time. You probably just don't know that that's what it is. So a ratio is it tells us the number of times one value is contained within another value. So what the heck does that mean? That just means that for every, or it could also be contained within another value, or contained, is contained on that value. So what that means, with all my babbling, is that let's do an example, because examples are so much easier. So I'm going to say these are game tokens that I have for my Game of Thrones Catan game. So I have for every one of these, I can't remember if it's a village in the game, but for every one of these, we have three. These are roads. So that in itself right there is a ratio. So for every one of these, we have three of these. There's that's their value. So let me write down the value just so we can see what that looks like, because the notation for ratios is a little bit different, and sometimes when we change the notation for numbers in mathematics, that's what kind of throws our students for a loop. So we just have to be transparent about how we are doing things and what things different things mean. So for every one of these, I'm going to put, this is a village. So for every one village, we have 1, 2, 3 roads. Now with ratio notation, this can be a notation that you use, this semicolon or this colon. So for every one village, we have 3 roads. That's one way that you can write this ratio. You could also write it for every one village, we have 3 roads. Or you can write it out. For every one village, we have 3 roads. Now, you can think around the house about all kinds of things that you have. So for every 3 bedrooms, you have 1 bathroom. So if we wanted to use that same ratio, how many bathrooms would we need for 6 bedrooms? Or if you're making something in the kitchen, I know I make my own spaghetti sauce, not any of that canned kind of nonsense, but I make my own spaghetti sauce. So when I make my own spaghetti sauce, I have for every 2 cans of sauce, just the tomato sauce, I have 1 can of crushed tomatoes. That happens in cooking all the time. So you might think, well, then why is this such a big deal? Because it really is a big deal in 6th grade. So what's the problem with all this stuff? The issue with ratios and what we have to do with ratios is we need to be able to use them in a context. So let's say I'm not making just 1 batch of spaghetti sauce. I'm making a couple of batches of spaghetti sauce. But if we know that this is what gets the flavor the way that I want it to be, then we know we have to replicate that flavor. Same thing with anything. So in a game token, if we know that in order to get 1 of these tokens, you need to have 3 of these, then we can figure out, okay, if I want to get 3 of these, the yellow villages, how many roads am I going to need? It really, if you walk it through, you talk it through, it makes sense. The problem is we go straight for the notation when we teach ratios too often and too quickly. So at home, this would be great for you with the students that you're working, is to just really practice these in real life. So using a recipe, using game tokens, using something that they can feel and touch and play with. So let's play with these for just a little bit. So I'm going to use this ratio again. So for every one village here, I need 3 roads. So I'm going to write, actually, let's just play with it for one. So here's our one ratio. Now, there are a few things that you could do. Now, I could say, okay, I don't want just one village. I want 2 villages. So now we have 2 villages, but their partner, the partner isn't here. So the value of the other part of the ratio isn't here. So there's a couple ways you can do that. This is one chunk. For every one village, there's 3 roads. Here's another chunk. For every one village, there has to be, this is like completing a sentence thing here. So there has to be 3 roads here. All right, so if we wanted, for every one village, there's 3 roads, and the same thing is happening here, right? For every one village, there are 3 roads. But if we look at this combined, there's what? There are 2 villages for 1, 2, 3, 4, 5, 6 roads. 2 villages for 6 roads. So you can have 1 village for 3 or 2 villages for 6. Let's think about what you would need if I wanted 3 villages. So I know that we have to keep that consistent ratio. So we have 1, 2, 3 villages now, but this village doesn't have its partner here. So that means if we want 3 villages, we need to have 9 roads. So let's look at that one. We'll put that one over here. If we have 3 villages, that's 9 roads. So now, and these things you do many, many, many times. So you don't just do something like this once and then like zippity-doo over to the notation. You don't want to do that. You want to play with this for a while. And we all have enough time at home to play with these. So let's just play with them for a while. But let's write down this notation now, because this is pretty interesting what we figured out here. So if we have one village, that gave us 3 roads. That's this one right here. But remember what we did when we had 2 villages. When we had 2 villages, we had 6 roads. So I'm going to write that one down. 2 villages, 6 roads. My village and my road look the same. All right. Okay, so that's true. Now, what did we have when we had 3 villages? So when we had 3 villages, we have 9 roads. So I've used the fractional notation. You could also do this, 1 to 3, 2, and we read this, 1 to 3, 2 to 6, 3 to 9. So we can look at that notation, or you can write it out in words. But here's the really cool thing, and this, you don't go to this too soon, all right? You can go to it too soon and you don't want to. So once you start having your student write these things down, you can just say, well, what do you notice? What do you notice every time here? And then be quiet. So ask them the question, what do you notice? And don't talk, because they will learn very quickly that if you talk, they don't have to answer any questions. So just sit there patiently. I don't know, what do you notice? So hopefully they're going to notice some kind of patterning. So, and math is all about patterns. We're going to talk about looking for patterns in the math practices today, but it's all about looking for patterns. So they might notice that 1 of these and 3 of these means you can just take this thing and just multiply that by some number in the numerator and denominator. They could say, well, these are going up by 1. That's an interesting thing to notice. And if these are going up by 1, up by 1, up by 1, what's happening here? What's happening here? Those are going up by 3. Why is that? So these kinds of questions are just, you want to just be able to play around with, ask questions, and figure some stuff out on your own. And it's okay. It is okay to say to your child, I don't know. I'm going to try to figure that one out, because it's really quite nice for our children to know that we struggle with things too. So especially nowadays, there's a lot of stuff going on that people are struggling with, and we're human. So it's okay to struggle with this math a little bit, and to say, I don't know, let me check. Send us a message, and we'll respond, and we can check for you and your student. So this is using, these are called tactile tools, so that your student can pick things up and move them around. And using tactile tools is a really good way to make sure you're meeting all of your learners' needs. So some people just can write things down and get it lickety-split like that. Some people can just hear it and they understand it by that. But some people had to actually touch and move things. And actually quite a few people have to do something like this. So this is one way that you can do it. You can use this tactile kind of idea where you're expanding and reducing. We haven't done any of those yet, but where you're expanding and then simplifying things. So tactile tools are really good. The other tool to use a lot with ratios, it's pictorially. So that's what I did with the spaghetti sauce. So with our spaghetti sauce, I have 2 cans of sauce for every 1 can of crushed. So we can say, okay, if I have 6 cans of sauce, how many cans of crush do I need? So let's draw a picture of it. 6 cans of sauce. So we have 6 cans of sauce here now, but we don't have our partners. So remember, this is the complete ratio. So that's the one that's all together. So now, again, we did tactile. This is now pictorial. So we have to have, this picture has to look like this in some form, So if we have these other 2, we don't want to throw these cans of sauce in to our spaghetti sauce if we don't have the crushed, because then it won't be the right consistency. So that means in order for this taste to be the same, we have to have another can of crushed here and another can of crushed here. So now we have complete ratio. So it'll all taste the same. If we didn't have those other cans of crushed, it'd just be super soupy, and that's not good. So if we start, our regular recipe is 2 cans of sauce for every 1 can of crushed, then that means that this one is also 2 to 1, and this one is also 2 to 1. But if we wanted to make this whole batch, we have the first one is 2 to 1, sauce to crushed. Can you see that up there? And then the second one, or the whole thing, let's look at this whole thing here. This whole thing here, we really have 2, 4, 6 cans of sauce and 1, 2, 3 cans of crushed. And then you can look at this and wonder, what does this mean? Could we do this without drawing a picture? And let me just caution you, it's okay to draw the picture. You can draw a picture in 6th grade, you can draw a picture when you're in college. Pictures, models are what we do in mathematics. So if your student is drawing a ton of pictures, yay, that means he, she, or they know what they're talking about, or at least have an idea about what they want to do. So we have this, and we're not going to talk about any math. Now, I know those of you that are, well, most of you are adults, but I know most of you can look at something like this and say, oh, yeah, well, you just multiply this by 3, and whatever you multiply the top by, you multiply the bottom by, but we don't want to go there yet. That is true, and you can find ratios this way, but right now we're focusing on understanding what a ratio is. That's the key, understanding what it is. Next week, we're going to talk a little bit more about how to use ratios in problems. I'm going to do one more. It's a cooking example, so, but I'm going to use representations of the items instead. So let's say that we have 1 box of cake mix. So here's our cake mix. We have this 1 box. Oh, you can't see that very dark, can you? We have 1 box of cake mix. And we need 2 eggs for every 1 box of cake. But sadly, we didn't get to the store and we only have 1 egg, and we have the super urge to eat a cake, or at least some cake. So we want to make the cake and we want it to taste good, but we only have an egg. So this is a ratio also. This one says that for every 2 eggs, you can have 1 cake mix. Every 2 eggs, you get 1 cake mix. But we only have 1 egg. So what do you think we do? So you can pose this problem, to your student. What do you think we do? What do you think we do here? And be quiet and let them think and look. Well, we only have 1 egg. So most likely they'll want to remove this thing, this egg, which is a good idea because we don't have it. But then we have to think about, okay, so if we remove this egg and we only have the 1 egg with the cake mix, it's not going to have all the egg that it needs. So what do we have to do in this case? If we take 1 of these 2 away, we're going to remove 1 of the 2 eggs. Remove 1 egg. Okay? Which is really, now we have only half the amount of eggs that we had to begin with. We had 2, now we only have 1. We have 1 out of those 2, right? So if we remove an egg, that means it's not good then for this whole cake mix anymore. So what do you think we could do? We only have half amount of eggs. We could take half the cake. So I'm going to do that. And I'm just going to cut my cake in half. So if I had my powdered cake mix, I know that if I have 2 eggs, I can make the whole cake mix. But if I only have 1 egg, that means I have to remove some of the mix. Otherwise, it'll be too floury and powdery. And so in order for it to be the same ratio, we have to then remove these. This is a conceptual model of how we do ratios. So we can do these, and I'd love you if you would do these with your students over and over again, and just try. You can go backwards, which is what we just did here. We started with more, and then we removed chunks, and we're not removing singles. We're moving a part of this whole. So the whole number of eggs was 2. We removed 1 of those 2, or half the eggs. And if we do that, we have to remove 1 of the 2 pieces of cake mix. Well, it didn't come in 2 pieces to begin with, but we chopped it in half and we removed 1. So what we're doing is we're taking half of each of those items out of our mix, which should make it good. Now, you can actually do this with food when you want to make anything, especially if it's just 2 different items. If you're making oatmeal in the morning, use the regular mix and then say, okay, what if I just wanted half the amount of oatmeal or anything, especially in the kitchen? What if I just needed half of that? Or what if I needed 3 eggs to make 2 dozen cookies and I only had 2 eggs? What would that mean? And I'm just going to leave this one here because we're going to come back to ratios. Ratios are incredibly important for the sciences. So today we just talked about what a ratio is, how you can use it with concrete models or tactile, how you use it with other materials that take the place of and you can just manipulate them, and then how to use it in pictures. Tomorrow or next week we'll talk a little bit more about how to use ratios to find things that are missing And but play with these kinds of ideas for a week. Just play. Don't scooch into the standard kind of format really quickly. We just want them to play right now. All right. So, and you can play with math too. So hopefully we'll see you next Monday. We're going to have a part 2 to ratios, and I'll hopefully see you next week.